Hello dear students, welcome to Pen and Paper Chemistry on YouTube. We continue with the topic of amines and this is part 6 of the topic and we shall be dealing with the properties of amines. Please don't forget to like and share the channel Pen and Paper Chemistry for more insight into other topics in chemistry. Let us start with the physical properties of amines first. Amines are very fishy compounds, meaning to say that they are associated with an unpleasant odor. The lower members, as in the case of any homologous series, are usually gases. Higher members turn liquids or solids. Aromatic amines, on the other hand, are either liquids or solids. When they are pure, amines are usually colorless, but when left open or exposed to air for a long time, their color becomes dark, and that is because of the oxidation that takes place in the case of amines. So, if you see a colored amine, that means it has impurities in it. Boiling point, a very important property of any compound. We notice that the boiling point of amines lies in between that of alcohols and hydrocarbons. Now we know that alcohols are famous for hydrogen bonding, whereas hydrocarbons do not show hydrogen bonding. When we notice that the boiling point of amines is in between that of alcohols and hydrocarbons, so we know that there is something fishy over here, and that fishy thing is the hydrogen bonding. So yes, they do undergo hydrogen bonding like alcohols, but because of the lower electronegativity of nitrogen compared to oxygen, you see, this is the electronegativity order decreasing like this. So, FON, fluorine, oxygen, nitrogen. Since the extent of hydrogen bonding will be lower when the element is nitrogen, we notice that the boiling point of amines is, although higher than hydrocarbons, it actually is lower than that of alcohols. Hydrogen bonding is a very important concept in organic chemistry. So please make sure that your fundamentals on intermolecular and intramolecular hydrogen bonding are very clear. Most of the behavior of organic compounds, the odd behavior of organic compounds, can be easily explained by their ability to form hydrogen bonds. And we already have a video in place on the channel for you to understand. Now from that video, if you remember, we've already spoken about the hydrogen bond in the case of alcohol. So you see over here, oxygen is electronegative, hydrogen becomes positive, negative, positive. The hydrogen from one molecule attracts the oxygen from the second molecule, and that is how we have hydrogen bonding in the case of alcohols. This is here, negative, positive. Now, if you notice in the case of amines, a similar bonding is possible. So, I have here nitrogen, which is electronegative, there is hydrogen. So, there is nitrogen, there is hydrogen, there is nitrogen and there is hydrogen. So negative attracts the positive and they develop a friendship which we call as hydrogen bonding. Here I have two hydrogen atoms which are capable of forming hydrogen bonds. What if one of the hydrogen was replaced by another alkyl group? Now I have only one hydrogen atom available to form a hydrogen bond. Now third step, Imagine that this hydrogen is also replaced by an alkyl group. So what happens to the extent of hydrogen bonding? Yes, it goes down drastically because there is no hydrogen available. So what do you think would be the order of boiling point for a primary, secondary and tertiary amine? So when I am talking about primary, I have RNH2. When I am saying secondary, I have R2NH. When I have tertiary, this is how it is. So what will happen to the extent of hydrogen bonding? Yes, it is going to go down in the order, primary greater than secondary greater than tertiary, and this also explains why the order of boiling point in the case of amines is primary greater than secondary greater than tertiary. More the number of hydrogen atoms, more the extent of hydrogen bonding. I will keep this on the screen so that you can copy down the notes for offline reference. And if you are confused about the concept of hydrogen bonding, please make sure that you watch the video on hydrogen bonding and clear your concepts. Very, very essential. It's a very important topic. There you go. You can take down the notes. They will come in very, very handy for you when you are not watching videos on YouTube and you are busy preparing for your exams. All your lessons consolidated in one place. I can draw this hydrogen bonds for you once again so that your concepts and your notes are clear. There you go, and then you draw the hydrogen bond. Yes, we've drawn a 2D structure. We've not drawn a pyramidal structure so that the concept is easy to understand and it's more comprehensible. There you go, R and H, negative, positive. Okay, but yes, remember that in the case of alcohols, here there's an oxygen. Although there is only one hydrogen, there's only one OH, but there is oxygen over here in the case of alcohols, and oxygen is more electronegative. So the extent or the strength of the hydrogen bond will be stronger in the case of alcohols. Written it down. We shall apply the same logic of hydrogen bonding to explain solubility as well of aliphatic amines. So as can be seen, in the case of lower amines, because this hydrocarbon part is smaller, they will be soluble in water due to what we call as intermolecular. Inter means between two molecules, intermolecular hydrogen bonding. And can you recall the other type of hydrogen bonding? Yes, I mentioned just a while ago, intramolecular. For example, in the case of orthonitrophenol, remember we spoke about hydrogen bonding in the case of orthonitrophenol, where there is hydrogen bonding within the molecule, and that affected its physical properties greatly. But again, remember, the electronegativity of nitrogen is lower as compared to oxygen. That is why the solubility of amines is lower than the solubility of alcohols. Secondly, there are more hydrogen atoms and there are hydrogen atoms which can share. So if I am talking about a primary amine, I will have R, N, H and an H. Now this hydrogen can also form bonds with water molecule. So that means more the bonds, more is the solubility. Now in second step, now this hydrogen is replaced by an alkyl group. So that means, is this hydrogen bond possible? No. Now there's only one hydrogen bond. Third step, you replace the third hydrogen also by an alkyl group. Now what is there is the nitrogen, only the nitrogen can form a hydrogen bond with water molecule. it cannot act as a proton donor. It can only act as a proton acceptor. That is why the solubility order for primary, secondary and tertiary amines would be primary greater than secondary greater than tertiary. Also, with increase in the number of alkyl groups, so you see over here, in the case of primary I have only one alkyl group. In the case of secondary I have two alkyl groups. Now this alkyl of ours does not like water. It does not like means water is hydro, does not like phobic. It has this phobia of water. It is a non-polar part. So because of the increase in the hydrophobic part in a tertiary amine, what will happen is again the solubility will go down. So we notice that in the case of higher amines with greater than 6 carbon atoms, the solubility actually goes down due to the increase in the non-polar hydrophobic part. Now this is what we call as a keyword when answering a question. Remember, at the end of the day you have to sit for your exams, and that is why you are on the channel trying to learn for that. Aromatic amines on the other hand are insoluble in water due to the bigger hydrocarbon part. An interesting observation, amines are soluble in organic solvents as well. So for example, ether, benzene, alcohol, etc. Again, I am going to keep this on the screen for you so that you can take down the notes for offline reference. I am also posting these notes on the Google site Pen and Paper Chemistry. If you Google Pen and Paper Chemistry, it will bring you to this channel as well as the site. So it's Pen and Paper Chemistry Google site. It is right. So in case you miss out anything, although it is in your best interest, please write it down. Whatever you are seeing here, write it down. It is very, very important. At least once when you will write it, it will remain longer in your mind. In the next video, we shall continue with the chemical properties of amines. So do come back or do move on to the next video to continue learning chemistry in an easy and fun way. See you soon.